Hello everyone and welcome to our poster presentation on cross-domain detection of AI-generated text. My name is Navya and I'll be presenting alongside my teammate Jailesh. Together we have developed a system that not only distinguishes human written text from AI-generated text but also identifies which model produced it across both familiar and unfamiliar content domains. Today we are tackling a challenge that's becoming more common in the age of AI. Like, can we tell who wrote a piece of text, whether a human or an AI model like ChatGPT or DaVinci? AI-generated content is everywhere, from school assignments to product reviews to social media. While some of it is really helpful, it can also be used to spread misinformation or bypass any human written standards. So knowing who wrote that really matters for AI safety and trust. Now, most existing solutions try to detect if text is AI generated or not. But we go a step further. We try to identify the specific generated model. Was it ChatGPT, Cohere, or Bloom's? This is called multi-generated text classification. But here is the catch. Top performing systems usually work well only on benchmark datasets. They fail to generalize when the data comes from the real world sources like Amazon reviews or a movie comments. That's the gap our project tries to address. So, the goal of our project is cross domain generalization. We train models on general internet content and then test them on new unseen domains like product reviews and movie reviews. Now, hand it over to my teammate who will walk you through the how we have built the system from end to end.
Thanks, Navya. Let's dive into our approach. We used a dataset from a SemiWell 2024 competition, which includes both human-written and AI-generated text. And we also created our own cross-domain test sets, one from Amazon reviews and one from IMD movie reviews. By generating text using prompt engineering across 6 different label types: human, ChatGPT, DaVinci, Cohere, Blooms, and Dolly. So our pipeline begins with data processing step. We first split the dataset into train and validation sets and then tokenize the text using Hugging Face tokenizer. So next comes model training. So we fine-tune 3 lightweighted transformer models like Robota Base, Digital Robota Base, and Debutta V3 Small. And all these 3 models were fine-tuned using LoRa, a method that lets us train efficiently by updating only small parts of our model, saving memory and time without losing performance. And also during the validation phase, we try different hyperparameters such as learning rate, batch size, and dropout to find the best performance settings. This this helps us avoid under overfitting and improved our model performance. After training, we evaluated each model on 2 types of test sets: in-domain test set from the same semi-well distribution and cross-domain test set, our custom Amazon and movie reviews. So we then extracted the model logics, which were the raw prediction scores. Then we calculated the individual accuracy for each model on both in-domain and cross-domain test sets. This gives us a baseline for comparison before we move to combining models. Next, we used these logics for ensembling learning using 3 techniques: soft voting, which averages the logics from all 3 models; weight soft voting, which we give more importance to better models like Robota; and majority voting, which picks the most common predictions across the models. So for each test set, we predicted labels using these ensemble methods and then compared them to true labels using metrics like accuracy, F1 score, and confusion matrix. This way, we could not only see how individual models perform, but also whether combining models improve the results. So now back to my teammate to share what we have discovered from these results.
Thanks, Jagdish. Now on to what we have found. First, on in-domain data, the models performed really well. Robota base hit over 96% accuracy, and ensemble methods like soft voting slightly improved it even more. But on cross-domain data like Amazon reviews, performance dropped significantly. For example, Robota's accuracy dropped to 21% on Amazon reviews, and even the best ensemble setup only reached about 33%. Why the drop? Well, we trained the models on general internet content, but the test sets had domain-specific language from product and movie reviews. We believe that if we had trained on domain-specific data, the results would have been much better. So, what did we learn? One, even small LoRa-tuned models can perform well when fine-tuned properly. Two, is that ensemble techniques help improve cross-domain results a bit without needing more training time. And three, models do not work well on benchmark datasets as they may struggle when tested on different kinds of real world data. In future work, we wanted to explore domain adaptation, develop prompt specific detectors, and extend our method to multilingual settings for broader use. Thank you. Thanks for listening to our project.